Welcome to Argument Basics. In this video, we'll take a brief look at some common deductive arguments. Now, as I mentioned in previous videos, they're arguments. So they got one conclusion, the point being argued for, and one or more premises. And arguments can have unlimited premises. Now, with deductive arguments, they have a formal structure. And as we saw in earlier videos, they split into the valid and the invalid. And a valid argument is such that if all the premises were true, then the conclusion must be true. Now, one important feature of deductive arguments is that their validity is a matter of their structure, how they're built. So if an argument is valid, any argument with that same form or structure is also valid. And we can use a couple comparisons here. Think about like math, because everyone loves math. If you have a formula that works in math, anytime you use that formula, appropriately of course, it's going to yield the correct answer. Also, like in say business, calculations. If you have a formula that properly calculates a mortgage, whenever you plug in numbers into that formula, you'd get the correct answer. If the information goes in as true, then what comes out would be correct. Another comparison would be, think of like the plan for a house. If a house is built on a plan, if a house is built on another house is built on the same plan, it'll have the same layout, assuming the plan is followed. And so with the structure of a valid argument, it is built in a way that's correct. You put in true premises, you get out a true conclusion. And you can think of it as a good formula, or if you've ever used Excel, think of it as a good formula in Excel, or a good design. So some deductive arguments are so well known that they get their own names. And these include the modus ponens, the modus tollens, hypothetical syllogism, and disjunctive syllogism. And these are about 4 examples. In theory, there could be an infinite number of valid deductive arguments. Obviously, we won't present them all because, you could just spend infinity going over them. So the first and really well-known one is known as modus ponens, which means the mode of affirming. It's probably more commonly known as affirming the antecedent, because in a conditional claim, an if-then claim, the first thing here is what's called the antecedent. From ante, it's the first thing. And then after the then is what's called the consequent, which is why it's called affirming the antecedent. So the first premise is if P, then Q. The second premise is P, the conclusion Q. And it's valid reasoning, because if you put in true premises, you're guaranteed a true conclusion. So simple example, think of like a days of the week example. So as I'm recording this, today is Tuesday. So premise 1 would be, if today is Tuesday, then tomorrow is Wednesday. Premise 2, today is Tuesday. Conclusion, tomorrow is Wednesday. Clearly good reasoning, because if Tuesday is always followed by Wednesday, and today is Tuesday, tomorrow's got to be Wednesday. Now, this also shows why valid doesn't mean the same thing as sound, because this argument is always valid, but not always sound. Take, for example, a Monday argument. If today is Monday, then tomorrow is Tuesday, which is true. Today is Monday, which happens to not be true when I'm recording this. Conclusion, tomorrow is Tuesday. Now, that's also, false. So you may be thinking, how can this be good reasoning? Well, think of this. If today was Monday, what would tomorrow be? Yeah, it would be Tuesday. So validity is not about whether the claims are true or not. It's about whether the logic is good. You can have good logic about stuff that's not true. To use a final kind of analogy or metaphor, think of taxes. Everyone loves taxes, like they love math. If you buy tax prep software, what the company promises you is if you put in all the correct information, you'll get the correct amount at the end. But if a person just starts making up stuff, income, $1 billion, just make up numbers, the company's not, liable or at fault because their promise is not you'll put in true stuff. Their promise is if you put in the correct information, that they'll give the correct result. Likewise for valid arguments. They say, hey, give me truth, I'll give you truth back. Give me false stuff, no guarantees. Our second very common valid argument form is the modus tollens, the mode of denial. This is also known as denying the consequent, because that's what it does. So the first premise is if P, then Q. Second premise, the denial part, not Q. And the conclusion, not P. For example, if today is Sunday, then tomorrow is Monday, which is true. Tomorrow is not Monday, so today is not Sunday. Perfectly good reasoning. Now, once again, just because the argument's valid doesn't mean the premises are always true, because this argument is always going to be valid, but of course, it's only going to work on days that are not, not Sunday, because on Sunday, then it would obviously tomorrow would be Monday, so the second premise would be false, and the conclusion would be false. Now, again, it's about the correctness of the reasoning, which can be kind of like confusing. People say, oh my God, how can this be false stuff in good reasoning? Again, think of like doing the math in a math class. You suppose you're learning how to calculate a mortgage or do like a physics problem with all kinds of, stuff going on in it. And if you were calculating, say, like a rocket trajectory, you're calculating how a rocket, should go to reach Mars. You obviously don't have to go and build a rocket and shoot it off to get the math right. You can do the math correctly, even though you don't have a rocket and you're not shooting it to Mars. And so all the information could be untrue, but it's the quality of the reasoning. So a third common one is what's called a hypothetical syllogism, sometimes called a chain argument, and goes like this. Premise 1, if P, then Q. Premise 2, if Q, then R. Conclusion, if P, then R. And to illustrate this, you could take an example of like getting from here to there. So if you're in Tallahassee, then you could get to Atlanta. And if you're in Atlanta, then you can get to Maine. Bangor, Maine, let's say. So the conclusion, if you're in Tallahassee, then you can get to Bangor, Maine, makes sense. I mean, not an earth-shattering argument, but it shows this is good reasoning. If P gets you Q and Q gets you R, then P gets you R. And as with all arguments, this is quality of reasoning as opposed to whether these things are true. I mean, for example, to use a silly example, think of a made-up world like in The Lord of the Rings or The Witcher, etc., where you have fictional places. And you can, if you can get from, the Shire to, Gondor, and from Gondor to Mordor, you can get from the Shire to Mordor, to use a Lord of the Rings example. But of course, those places don't exist. This is all made up. But the logic is still good. Finally, we have the disjunctive syllogism. The first premise is P or Q, and there's put in a little logical notation in there that V is or. Premise 2, not P, conclusion Q. So you can think of like the logic of sports. If you have two teams playing, one team wins or the other wins, laying aside, ties, etc. So if the first team didn't win, the second team must have won. So if you have the Yankees versus the Red Sox and the Yankees didn't win, the Red Sox won. So good logic. And again, these are about reasoning, not about whether the content is true or false. So those are 4 common valid deductive arguments. Any argument built on them, regardless of the content, whether they're about, days of the week stuff or unicorns or whatever, will always be valid, just based on the structure. So what about some invalid arguments? So the invalid arguments, there's also potentially an infinite number of these. So obviously not going to cover them all. Now there are three that are so common that they get their own names. They're kind of evil twins. There's affirming the consequent, which is the evil twin, of affirming the antecedent. Now, these invalid arguments get names because they're kind of seductive. They seem reasonable, especially if you put in claims that are true and seem plausible. For example, suppose we take this. If Tallahassee is the capital of Florida, then it's in Florida. Totally true. Premise 2, Tallahassee's in Florida, which is true. Conclusion, Tallahassee is the capital of Florida. Also true. And that seems pretty reasonable. Everything I've said is true. It seems to make sense. But unfortunately, it is bad logic. How do we know? Well, obviously I'm giving an example of an invalid argument, so it's got to be bad. But we can test this using the informal method. So let's plug in some things we know to be true as premises and get a conclusion we know to be false, showing it's bad logic. So if Miami's the capital of Florida, then it's in Florida. True. Miami's in Florida. True. Miami's the capital. Not true. And so the logic is bad. And again, it's not because, I said something false. It's because you could have all true premises and a false conclusion. The other evil twin is what's called denying the antecedent, which is the evil twin of denying the consequent. And it also seems kind of, plausible. And that's why it, tricks people. So premise 1, if P then Q, premise 2, not P, conclusion, not Q. And it can seem quite reasonable. For example, if it is raining, then the sidewalks are wet. It's not raining, the sidewalks are not wet. Which you think, well, that sounds reasonable, until you think about it for a bit. You can think, well, maybe it just stopped raining. So it's not raining, but the sidewalks would still be wet. Or maybe someone was watering their lawn, and the sidewalks are wet, even though it wasn't raining. So all the premises could be true, but the conclusion false. There's also the undistributed middle, which is the evil twin of the valid hypothetical syllogism. And this one basically works by, or doesn't work by, breaking the connection. So if you have if P then Q, premise 2, if R then Q, conclusion if P then R. And as you can see, if P gets you Q and R gets you Q, it doesn't mean that P gets you R. For example, if you have $1 billion, then you could buy a candy bar. If you have $1, you could buy a candy bar. Therefore, if you have $1 billion, you just have a dollar. And so that could seem, reasonable, but just because if P gets you Q, doesn't follow that in R gets you Q, doesn't follow that P will get you R. Although there can be cases like the example there where you'd say, wow, all that stuff is true. If I have $1 billion, I can get a candy bar. If I have $1, I can get a candy bar. Therefore, I have $1 billion, then I have a dollar. And on one hand, you'd say, well, that's true, because if I have $1 billion, I do have $1. But if we change it to if I have $1 billion, then I can get a candy bar. If I only have $1, then I can get a candy bar. So if I have $1 billion, then I only have $1. It's silly, but clearly, false, because I would have $1 billion. There's also the, this one doesn't really have a common name, but just for the sake of, completing our evil twins, we have premise 1, P or Q, premise 2, P, conclusion, Q. And obviously this doesn't work as good reasoning because, again, go to the sports example. We've got, say the Red Sox versus the Yankees, one team wins and we say the Red Sox win, therefore the Yankees win. And that obviously would not follow. So those are 4 common valid deductive arguments, 4 common invalid deductive arguments, but there are billions, perhaps an infinite number, probably an infinite number of valid and invalid deductive arguments, which is why we don't have like a big book of all the deductive arguments. So that takes us to the end of looking at some basics for deductive arguments. Now, if you want to learn more about deductive arguments, this would generally, require like a lot more stuff, typically covered in a full class on, logic. You can have obviously, you can spend a whole class just on deductive arguments. In fact, you could take class after class after class if you want to go to philosophy grad school on deductive arguments. So that's the basics of deductive arguments.